So here we go, lesson 1.2. We're talking about the order of operations, with our focus today being on evaluating numerical expressions by using and following the order of operations. Again, evaluate means to find the value of an expression. We'll also evaluate algebraic expressions by using the order of operations. The main difference between a numerical expression and an algebraic expression is that an algebraic expression will have variables. Again, focusing on the order of operations, we may remember PEMDAS, or please excuse my dear Aunt Sally. So as we look at PEMDAS, and what does that acronym stand for? The P stands for parentheses. As we take a look here, and again, parentheses come in a variety of shapes and sizes. They can be different parentheses, brackets, grouping symbols. Sometimes the absolute value sign will act like parentheses in the order of operations. Also, if we have a fraction bar, we need to do what's in the numerator or on top first, and then in the denominator or on the bottom separately than from what we do in the numerator. Next we have E, that's our exponents. So after we've taken care of anything with parentheses, we need to work with exponents. Then we get to the M and the D, and again this is multiplication and division, and again these two need to be treated as equals. I multiply or divide, whichever one comes first, in order from left to right as we'd read a book. So if division comes first, we take care of that, then the multiplication. That's just a common error where we say multiplication first, but they're equals. Addition and subtraction are similar. Okay, we need to make sure we add or subtract in order from left to right. So whichever one comes first, we take care of that. So now jumping into some of our samples. We'll work with number 1 first. As we take a look, there are no parentheses, but we do have the exponent, 4 to the second. So we copy everything else down as it is. So 15 divided by 3 times 6, we leave, and then we go ahead and square 4, and that is minus 16. At this point, we move on with our thought of PEMDAS, and again, multiplication or division in order from left to right. This case, division comes first, so I'll divide the 15 divided by 3. That gives me 5 times 6 minus 16. Again, moving on, we can multiply the 5 and the 6 now. That's 30 minus 16, and that gets us to a final answer of 14. Okay. As we look at example number 2, we have parentheses. In this one, I could have written it as 2 times 5 using a dot. With the computer, it's easier for me to use parentheses. I'm going to leave that alone, and I'm going to tackle the 4 plus 3 first. So 2 times 5, write a more traditional symbol for the multiplication, plus 3 times 7. Okay. At this point, I have the 2 times 5 as well as the 3 times 7 separated by an addition sign. So I can go ahead and multiply those both at the same time and get 10 plus 21. And our final answer here will be 31. And again, just for those of you in class, notice that I'm showing all my work. Okay, I'm not just jumping to, in problem 1, the answer of 14, or in problem 2, an answer of 31. I'm showing the work to get there. So now we look at number 3. Here we've got a lot of different things. We've got brackets or parentheses. We've got exponents. Want to focus on the 30 divided by 6 to the second power. I need to take care of the division first in this setting. So I need to go 2, just copy the rest of this down, plus whatever is in the parentheses here. So 2 times 5 plus 30 divided by 6 is 5. And we'll need to square that. And at this point, we can do this exponent, and we get 2 times 5 plus 25. And that will lead us to 2 times 30. And as I get to the bottom of my screen, I'm going to have to write to the side, and our final answer is 60. Okay, again, a number of different things going on there, but I think we've had enough practice through pre-algebra where hopefully we're confident with that. Looking at number 4, again, I have the fraction bar. That acts as a division symbol, but also a grouping symbol. So I need to work with the numerator and the denominator separately. 6 plus 4, that is 10. On the bottom, we have 3 to the second. That gives us 9 times 4. Continuing that out, we get 10. That's a 10, not a 16. My whiteboard, for those who've been in class, know that it gets a little tricky over on the right-hand side. So I'll rewrite it over here. That's 10, 36. We need to, at this point in math, go ahead and simplify this. We can go ahead and divide by 2 if that's what we happen to see, and we get 5/18 as our final answer. Here are a couple that you certainly can go ahead, work out, and try on your own. Please hit pause and copy those down. So number 5, we should end up with 4. Looking at number 6, we can go across and we get 36 minus 8 over 4 times 10. That simplifies down to 28/40. Many of us might just divide by 2 right away, and that will get us to 14/20. And then we can simplify that again, and it can get us to 7/10 as our final answer. Okay, looking at example 7. Okay, I didn't talk through a lot of these problems. Hopefully at this point we're able to see the work and recognize what we need to do. If not, please come to class with questions tomorrow. Okay, here we need to evaluate an algebraic expression. So the first thing that I need to do is substitute for the variables. So we'd copy the problem down. We have a to the second. In this case, a is 7, so we have 7 to the second minus the quantity of b to the third minus 4 times c. b to the third ends up being 3 to the third minus 4 times 5. And now again we need to go back and follow the order of operations. We get 7 squared minus 3 to the third is 27. Minus 20. Can go ahead and take care of the 7 to the second. I could have done that up in this step also. That is 49 minus 7. And we end up with the final answer of 42. And then taking this into a word problem, real life setting. So we have market research that shows an average consumer spending $78 on a trip to the mall on a weekend. On the weekdays, maybe they have less time, they tend to spend a little bit less. They spend $67 per trip on the week. So they want us to make an algebraic expression that shows how much the average consumer spends at the mall in X weekend trips and Y weekday trips. So in 4A, as we take a look at that, we know we go $78 on the weekend So that's $78 in X trips, or 78 times X, plus the amount of money that we spend on weekday trips, which happens to be $67, and the variable they're asking us to do on weekday trips is Y. So we end up with 78X plus 67Y. On part B of this, they go ahead and tell us, okay, we make 5 weekend trips, and we went twice during the week. So we're substituting, twice is a fancy way of saying 2 for Y, and 5 goes in where the X is. So we get 78 times 5 plus 67 times 2. We can go ahead and simplify that. Okay, and working out the 78 times 5, we end up with $390. The 67 times 2, again, if we needed to, some of us will do this in our head. 14, 12, 134. So you have $390 from the weekend trips plus the $134 on the weekday trips. We combine those, and we end up with $524. So that kind of sums up what we are covering today. The assignment here is for tomorrow. We'll work on that in class. If you have any questions, please write them down and be prepared to ask those in class. Apologize, today's lesson went a little bit longer. We're closer to a 12-minute mark than 10. Hope you have a good evening. We'll see you tomorrow.